Hey everyone, my name is Venerin, and in this video we're going to have a look at an essay called Situational Awareness by an ex-OpenAI researcher called Leopold. In this essay, the author describes what will likely unfold within the couple of next years as far as AGI and ASI is concerned. Let's get started. This is the X account of Leopold, and I can't really pronounce his family name, so sorry for that. And here you can see that he actually pinned the essay itself, which is available on the situationalawareness.ai webpage. And here he also posted some very good critiques from readers, which we're going to have a look at the next couple of parts of this video. Before starting with the essay itself, I would like to point out that there is a Hacker News thread that is based on the essay itself, and with that you can find a lot of criticism that is associated with some of the author's work. But keep in mind that the author, at least this is my opinion, is very much entrenched within the OpenAI and AI WAPs in the Silicon Valley in general. So while there is some valid skepticism and probably another understanding of technical feasibility and probably economical impacts, such as whether or not companies are actually going to put out so much money in advancing AI, all of those are pretty much addressed right here. But even though those are some valid points, we're going to continue with the author's work and just keep an open mind. So this is the front page of situationalawareness.ai. I'm using a plugin for easier readability. If we skim through the table of contents, you see that this essay is actually 5-part essay with some subparts right here. And in this video, we're going to go through the first one, which is called From GPT-4 to AGI, Counting the ohms. And this is essentially counting the order of magnitudes improvements since GPT-4 to what we need in order to get an AGI. So if you go through this, you see that the author describes that probably the most important place to be right now if you're interested in AI is San Francisco. This is essentially the heart of the Silicon Valley. Of course, this is a perspective from a US citizen, because we don't really know about what is happening in China, Russia, etc., what the AI research is doing over there. Not really sure about that. And he specifically says that behind the scenes, there is a fierce scramble to secure every power contract still available for the rest of the decade. Every voltage transformer that can possibly be produced. So there is a lot of competition for each and every GPU and CPU and memory, etc. You know that large companies such as Elon Musk's ex-AI, Microsoft, Google, etc. are scrambling for GPUs, more likely than not. And he says that the AGI race has begun. We're building machines that can think and reason. Of course, this is very controversial because we have, historically speaking, had a lot of thought about what is thinking and reasoning and how can we detect it within the machines that we're building. And if you recall the original Turing test, we are way past that, and nobody is even talking about that anymore as a test of intelligence. But again, we are way past that. And he says that willful blindness by some people that are mainstream speakers say that these types of models are just predicting the next word. So this is essentially the LLM task that you are probably mostly familiar with. And he says that this ignorance to what is happening behind the scenes in these model capabilities is telling them that they are just predicting the next word. Of course, I put a note right here to note that essentially this is what we believe are the best available models, and probably some of the better models are not available to the public. Not really controversial opinion, I think. So he says that pretty much only a few hundred people, most of them in San Francisco, and the AI labs that have situational awareness. So only a few people are understanding what is happening. And we are going to be having a look into the future in the next couple of years to see whether or not those people truly know what is going to happen into the very near future. And the time frame of the author is 2027 in general for AGI. This is essentially put in right here, that he says that probably around 2027 we are going to be having artificial general intelligence. And if you want to have a look at the complete essay as a PDF, there is also a link to that. And right here, he has a very nice analogy with the Oppenheimer and the Manhattan experiment in general. So if you think about this, probably if you were living throughout the times of when the Manhattan Project was happening, from the outside, it might appear as nothing is happening. But if you were essentially working within the project, you will know a lot more. This is the first part of the essay from GPT-4 to AGI, counting the ohms or order of magnitude improvements. And the essay starts, or this part of the essay starts with that AGI by 2027 is strikingly possible or plausible. GPT-4 to GPT-2 to GPT-4 took us from a preschooler to a smite high schooler abilities in 4 years. And you might have a different opinion on that. But if you recall, GPT-2 was extremely limited model and very clunky, very slow, while GPT-4 and GPT-4o are actually really useful in the real world. So at least this is my subjective experience of those types of model between those 4 years of progress. And the author claims that we should expect another preschooler to high schooler sized qualitative jump by 2027. And he further argues that this could probably lead us to abilities of AI or AGI that is capable to do AI research, which is essentially the final frontier, if you think about it, on whether or not we are going to achieve artificial superintelligence. So this is a quote from Ilya, again, an ex-OpenAI employee, probably the brain behind the improvements from GPT to GPT-4. Look, the models, they just want to learn. You have to understand this. The models, they just want to learn. This is a very deep, even though it appears to be very basic statement. And it looks like that Ilya has understood that those types of models can give us improvements that are far beyond we could have imagined, at least in 2015, which is again correct. So the author continues that a decade earlier, models could barely identify simple images of cats and dogs. If you recall, we had the first ImageNet trained models that were essentially Google was displaying as whether or not they would describe a given image as a cat and a dog. And GPT-2 could barely string together semi-plausible sentences. If you recall, again, when you were calling the OpenAI API with GPT-2, it was pretty much waffable what is happening with the outputs, not usable at all. Again, this is history now. Now we are rapidly saturating all the benchmarks we can come up with. Yes, this is true. The benchmarks that we have are pretty much getting demolished every day, since the models are improving on a scale that is a bit hard to explain and understand why. And the author further continues, the trend ones are intense, and they were right. Of course, this is looking at the history. The model, they just want to learn, you scale them up, and they learn more. So this is essentially an extension of what Ilya has been saying. And the author makes this pretty bold claim. It is strikingly possible that by 2027, models will be able to do the work of an AI researcher engineer. And I would argue that this is essentially the final frontier or the final goal. If AI models can improve AI models, probably we will get to ASI or artificial superintelligence much faster than what we are currently doing. And he further continues that that doesn't require believing in sci-fi, it just requires believing in a straight lines on a graph. Of course, those straight lines might get broken and we might hit diminishing returns, but the author continues with why this might not be the case, and actually those trend lines might continue to be straight up. As we scale models, they consistently get smarter, and by counting the ohms, we get a rough sense of what model intelligence we should expect in the near future. And this is a rough estimate of what is happening, and the estimation that by 2027 or 2028, we have automated AI researcher or engineer, and we are essentially currently at GPT-4 level on 2023 year. Publicly, things have been quiet for a year since the GPT-4 release. You can probably have a sense of that since GPT-4 was released, a great model that did a lot of improvement compared to GPT-3.5. And it is currently thought that those types of models are essentially hitting a wall, and Sam Altman has probably publicly said that this is not the case, but they're trying to essentially have a ways to, let's say, slow down the improvement that is shown to the public. And the author continues that we're racing through the ohms extremely rapidly, and the numbers indicate that we should expect another 100,000x effective compute scale up, resulting in another GPT-2 to GPT-4 sized qualitative jump over 4 years. I mean, this is a huge improvement, something that we can't possibly comprehend how much of an improvement this would be. And he says that one very important thing on Unhobbling gaze, which he is going to explain a bit further, should take us from chatbots to agents. And then from a tool to something that looks like a complete drop-in remote worker replacement. So essentially, he argues that such a jump is going to give us remote worker replacements, which of course is going to be a huge step. So let's look at the last 4 years. GPT-2 preschooler, whoa, it can string together a few plausible sentences. It was pretty bad, actually. Then we had GPT-3, whoa, this with just some few short examples, it can do some simple useful tasks. GPT-3 was a very large improvement compared to GPT-2. And again, most of the time when you were prompting GPT-3, the results weren't that impressive. And I mean impressive in a sense that you would use this model in the real world. And this pretty much changed when we got GPT-4. This is the smart high schooler scale of this model. And they could write, or these types of models can actually write code. You are probably using it into your VS Code with Microsoft Autopilot. It writes very well. It can write tweets, emails, etc. And furthermore, it can do some high school competition math, which is arguably a very important skill for developing intelligence further. And again, it is beating the vast majority of high schoolers on whatever test we can give it. Of course, your understanding of these types of models may vary depending on your prompting abilities and the type of task that you are giving, but from what I've seen, GPT-4 and GPT-4o in particular are very powerful models when you are giving them specific tasks with either images and sentences or text, if you know how to prompt them, of course. So what is happening in the next 4 years? Again, we don't really know, but the author has some few hypotheses that he would like to explore. A mere decade ago, it was revolutionary for a deep learning system to identify simple images, again, digits or cats and dogs. Today, we keep trying to come up with novel, even harder tests that each new benchmark is quickly cracked. So these are pretty much the benchmarks and how fast we actually broke pretty much everything with the new models. This is the GPT-4 on various exams: chemistry, macroeconomics, statistics, calculus, etc., etc. And these are the percentile reports for each of the models. You can see that calculus is still quite hard for GPT-4. And this is pretty much the forecast of whether or not or how fast we're going to be having by an year from the release of GPT-3, I believe, on the math dataset. And the actual percent of completion was around 50, while the prediction was quite low. So we even surpassed this by a lot. And the author continues that some of the hardest unsolved benchmarks are tests like PhD level biology, chemistry, and physics question, which probably you and I can't possibly even try to understand, as the author has claims that he also don't understand what is happening and what type of questions are those. And he says, quote, 3 Opus currently gets 60% compared to in-domain PhDs who get about 80% on such exams, which is quite remarkable. These types of questions are probably one of the hardest that we can get and test for. So yeah, it appears that those models are actually improving quite a lot. We've also seen the power of compute when we were looking through OpenAI Sora demos. They really showed us that scale in compute is actually really important, and the author is going to be describing the main components that we need in order to scale to AGI. The first one, not really impressively or not really surprisingly, is compute. So we are actually using a lot more compute compared to before. Algorithmic efficiencies. So we were actually doing something like the transformers at the start. Then we did some attention. We did some sparse attention. And finally, we're currently doing something sparse mixture of experts models, which are much more efficient to train and do inference compared to the original transformer architecture. So we have some algorithmic efficiencies and probably a lot more efficiencies that are done behind the scenes that we don't know about. And then we have this thing that he calls unhobbling gains. By default, models warn a lot of amazing raw capabilities, but they're hobbled in all sorts of dumb ways, limiting their practical value. And he says that some of the algorithmic tricks and improvements that we can do in order to get some gains with those types of models. And he says that we can count the ohms, or the order of magnitude improvements along this axis, that is, trace the scale up from each in units of effective compute. 3x is half an ohm, 10x is 1 ohm, 30x is 1.5 ohm, and 100x is 2 ohms. So this is just giving you a scale. And we can also look at what should we expect on top of GPT-4 from 2023 to 2027. But keep in mind that we don't really know what is happening behind the scenes for OpenAI and other companies. We don't really know how much farther or better models do they have compared to GPT-4. We're seeing much more rapid scale-ups in compute, close to 5x the speed of Moore's law instead of because of mammoth investment. So essentially, what is happening behind the scenes and even in front of the scenes, if you will, a lot of companies are essentially throwing cash at NVIDIA, and probably some other companies that are trying to give them as much as compute as possible. You know what is happening with NVIDIA stock, etc. And the author continues that the San Francisco rumor mill is abreast with dramatic tales of huge GPU orders. We know that xAI has invested a lot of money into clusters and H100 machines. The investments involved will be extraordinary, but they're in motion. Again, those things are already happening. Those are not some just rumors, but we know that already what is happening behind the scenes. And this is the first thing that we need, the compute, and compute is already happening. I think that this is pretty much given, since you know that those companies are actually putting out the money. And the author continues that inference efficiency improved by nearly 3 ohms or 1000x in less than 2 years. So relative inference cost of 50% performance on the math benchmark. You can see that GPT-4 was quite an improvement on top of Minerva 540B. And then Gemini 1.5 Flash, which is a very recent model, is performing even roughly 30 to 40 times better as compared to cost per compute, which again is quite a huge improvement. So the models are getting faster and they're getting less expensive to use. That's a huge deal. That means 4 years later we can achieve the same performance for 100x less compute and much higher performance for the same compute. Okay, so this is essentially the relationship between the compute and the performance. Much higher performance for the same compute or same performance for 100 times less compute, which again is going to give us that exponential growth that we are trying to have a look at. And he says that effective compute doubles roughly every 8 months, which is again very something that we can, at least I can't really comprehend how much faster these things are going to get. And he says that we actually don't have a look at what is happening behind the scenes, even though he's an OpenAI ex-employee. But GPT-4 on release cost the same as GPT-3 when it was released, despite the absolute enormous performance increase. So the same cost, but much higher performance increase. So that this suggests that perhaps roughly half of the effective compute increase from GPT-3 to GPT-4 come from algorithmic improvements. Since the GPT-4 release a year ago, OpenAI prices for GPT-4 level models have fallen to another 6 and 4x respectively for input and output with the release of GPT-4o. And then the author talks about Gemini 1.5 Flash offers roughly between GPT 3.5 and GPT-4 level of performance, while costing 85 and 57x for input and output respectively, less than the original GPT-4 model. I mean, this is really mind-blowing if you think about it. Gemini 1.5 Pro claimed major compute efficiency gains, outperforming Gemini 1. Ultra while using significantly less compute. Again, algorithmic efficiency or improvement, mixture of expert architecture that led us to those improvements. Of course, probably many other improvements that are happening behind the scenes. Put together, public information suggests that the GPT-2 to GPT-4 jump included 1-2 ohms of algorithmic efficiency gains. And this is the scale on which the author is describing how much of an effect on the ohms the physical compute is going to get and the algorithmic progress. Over the 4 years following GPT-4, we should expect the trend to continue. About half an ohms per year to compute efficiency, or 2 ohms of gains compared to GPT-4 by 2027. So a very large increase indeed, just from algorithmic compute, algorithmic efficiency. That is, if we find better ways to do that. And we have a large problem that the author admittedly says that we can't really solve right now. There is a potentially important source of variance of all of this. We're running out of internet data. And you already know that even the open LLMs such as Llama 3, Y from the Chinese, Qwen, etc., are essentially training on a filtered out subsets of the common crowd dataset. And Llama 3 was even trained on 15 trillion tokens, which is a very large amount of data. And the author continues with that if you just do some epochs on the same data, your essentially your output is not going to be getting even better. And here the author continues that probably one way to overcome this is to ask the model to think a bit harder. And he compares the LLMs that are just spitting out tokens with what we humans do, what we essentially do when we open advanced mathematical textbooks or something like that, is that we generate these internal conversations and think about what is happening. So maybe in this way, he argues that we can break through some of the data limitations that we have. And he further argues that synthetic data is probably not the answer. Of course, this is going to be remain to be seen. But he says that AlphaGo was trained by imitation learning on expert human Go games. So this is essentially something that we are currently doing with the RLHF and the internet data. But the second step here was pretty much the more important one. AlphaGo played millions of games against itself. This let it become superhuman at Go. Remember, etc. He's talking about the famous move that was done against Leopold within the game. So he says that developing the equivalent of step 2 for LLM is a key research problem for overcoming the data wall, and moreover will ultimately be the key to surpassing human level intelligence. So one of the bottlenecks that we currently have is the data limitation, and this is a very real problem. So why and how we are going to be going through that remains to be seen, but he continues that key algorithmic ideas are becoming increasingly proprietary. I'd expect WAP's approaches to diverge much more and some to make faster progress than others. So here he's talking that essentially open source models will have a much harder time competing. Why is that? Because most of the smartest people on earth that are doing AI research are going to different labs, and those different labs are increasingly not publishing any research on the improvements that they're doing internally. Also, they're not releasing what type of data that they're using, and OpenAI is pretty transparent about that, pretty open about that. They say that they're not going to publish any of their internal, let's say, architecture, datasets, training methods, etc. So they are now just showing us the results of their work, but not how they came up with the results. And some of the people are saying that you should just think of OpenAI's GPTs as tools and nothing more. You might think about that what you will. And the final part of this process that we need to go through is the unhobbling. Most of us work through the problem step by step on a scratchpad that are able to solve much more difficult problems that way. Chain of thought prompting unlocked that for LLMs. So these are some of the techniques that were used in order to improve significantly the performance of the LLMs. And he's going through those here. Reinforcement learning from human feedback, pretty standard. It was pretty much the first way that we got those instruct type models. Chain of thought prompting. 10x effective compute increase on math reasoning problems. Essentially, you are asking the model to think through what is happening. Scaffolding. Ask the model to solve a problem, have another model make a plan of attack, have another propose a bunch of possible solutions, have another critique it. So essentially what is happening here is that we are having a more in-depth look in what agents might do for us, and those types of agents, how are they essentially improving the performance of those LLMs again. He's now talking about tools. He's talking about use of calculators and computers in general. If we are essentially going to give those types of models the complete computer capabilities of your even laptop or desktop machine, probably those types of models are going to be performing some very interesting tasks. He now talks about context length, and he says that context length is effectively a large compute efficiency gain. And we went from 2K tokens in GPT-3 to 1 million plus tokens in Gemini 1.5 Pro. And I even made a video on GPT-4o, which showed that even in somewhat hard tasks and tests, the context length or context size was very effectively used, and there was pretty much no forgetting of items within the context. And finally, we have some post-training improvements for reasoning evaluations. And he says that GPT-4, the current version, has substantially improved compared to the original GPT-4 one when released, according to John Schumann, due to post-training improvements that unlock latent model capability. I'm yet to have a look at what is happening behind the scenes here, and let me know down in the comments if you know what type of post-training improvements GPT-4 had. And he says that a survey by Epoch AI finds that techniques like this can typically result in effective compute gains of 5 to 30x on many benchmarks. So those types of techniques and tools essentially are going to give us probably another, let's say, 20 or 30% of the gains that we need in order to get to automatic AI researchers. And he is summarizing here that from raw LLM to chatbot, we get this improvement. So this is essentially the instruction training. And when we start to speak about agents or agentic behavior, you can see that probably we are going to have another or two just from those. And he continues that unhobbling is what actually enabled these models to become useful. I mean useful, or the author means probably useful in practice. They don't have long-term memory, since the model are incredibly hobbled still. They can't use a computer. They still mostly don't think before they speak, something that we pretty much do while the models don't. They can only engage in short and back-forth dialogues. Essentially, you can give it a task and ask it to come back within a week or month, etc. Those types of operations are currently not going through with those LLMs. And increasingly, those types of models are not personalized to your application. Just a generic chatbot with a short prompt rather than having all the relevant background on your company, on your work. And he says that with continued unhobbling progress, the improvements will be step changes compared to GPT-6 plus RLHF. By 2027, rather than a chatbot, you're going to have something that looks like more an agent, like a coworker. Okay, so just imagine what this might look like. And this has a lot of problems in itself. Solving the onboarding problem, GPT-4 has the raw smarts to a decent chunk of many people's jobs, but it's sort of like a smart new hire that just showed up 5 minutes ago. It doesn't know anything about the company, internal documentation, Slack, email communications, etc. And for example, via very long context to onboard models like we would a new human coworker. This alone would be a huge unlock. Yeah, just imagine that you add somebody new to your Slack company, and then this one is actually going to understand what is happening behind the scenes, understand what is happening within the company, and then you can essentially, after a couple of minutes or hours, you can give it some tasks as if this AI agent or bot has been working for a company, for example, for 1, 2, or 3 years. Most useful cognitive work humans do is longer horizon. It doesn't just take 5 minutes, but hours, days, weeks, or months. The test time compute overhang. So here he essentially is comparing the number of tokens with equivalent time of working on something for few minutes, half an hour, half a workday, a work week, multiple months within a million tokens. And those types of improvements will allow it, or will allow those types of models to do something that you might make for a month to be essentially done within an hour or even less. So he is describing joining the Zoom calls, researching things online, messaging, emailing people, reading shared docs, using your apps and dev tooling, etc. That is, if you're going to give those types of models, have a look at what might be to be a drop-in remote worker. So this is essentially what something that Devin is trying to do for you. But again, this is just in the infancy stage, I believe. So here the author continues that what the next couple 4 years perhaps will look like. So he was probably estimating the compute, the algorithm efficiency, and unhobbling OMPs from GPT-2 to GPT-4. And the projection is that the compute is going to be probably scaled down. The algorithmic efficiency is going to be something that pretty much is going to remain the same. And chatbot to agent, system to thinking from Daniel Kahneman, probably understanding or fighting the onboarding problem and using or giving a computer to the agent. Probably those are going to give us a lot of umps as well. Putting the numbers together, we should roughly expect another GPT-2 to GPT-4 size jump in the 4 years following GPT-4. And he says that probably this is going to be expected by the end of 2027. Again, automated AI researcher around 2027 compared to what we had right here, depending on the OMS. And some of the concluding remarks, at least for this first part, we are on course for AGI by 2027. These AI systems will basically be able to automate basically all cognitive tasks, all jobs that could be done remotely. So probably your job too, mine as well. To be clear, the error bars are large. Of course, nobody knows the future, only probably the people that make it, but we're not one of those. And he speculates that we might hit a wall, for example, with the data or compute, etc. This could happen. But what is evident is that a lot of companies are putting a lot of money and a lot of talent on the task of solving AGI. Take the possibility of AGI. Through AGI by 2027 is you must be taking this extremely seriously. And he continues that once models can automate AI research itself, that's enough. So this is essentially the end game, enough to kick off intense feedback loops, and we could very quickly make further progress. I would argue that this is probably happening already. We don't really know what are the models behind what are the latest models from OpenAI, Google, etc. They're probably not going to be released in public, and probably all of those models have already read through a lot of the AI research that we currently have, and probably a lot of the other research that we currently have, and probably some of those models are already helping, if writing code, optimizing, delivering MLOps, etc., and even probably designing new structures for those models and new architectures. The automated AI engineers themselves solving all the remaining bottlenecks to fully automating everything. So essentially, what he says that if we get to AI researcher or automatic AI researcher, these types of models are going to be essentially giving us the next version and the next version, and we are going to essentially create this tight feedback loop that will get us to AGI or ASI even further, even easier. AGI will merely be a small taste of the superintelligence to follow. Yeah. As with every generation before them, every new generation of models will dump out most onlookers. They'll be incredulous when very soon models solve incredible difficult science problems that would take PhD days when they're whizzing around your computer doing your job. When they're writing code bases with millions of lines of code from scratch, when every year or two, the economic value generated by those models 10x's. Forget sci-fi, count the OMS. It's what we should expect. AGI is no longer a distant fantasy. And here he is giving us a progress of GANs. If you were here on 2014, these were pretty much the faces that were generated by GANs, 2015, 2016, 2017, and then 2018. And currently, if he did put a lot of images right here, you would see that we are getting pretty much photorealistic human faces already. And he is essentially added something on top of the conclusion right here. I've changed my mind critically. Our uncertainty over what it takes to get AGI should be over ohms rather than over years. So he changed his stance on the year estimate. Rather, he says that we should be having a look that we are actually racing through the order of magnitude improvements much faster compared to his original estimates. And he says that we'll do another 5 order of magnitudes improvement in the 4 years next, and over 10 ohms this decade overall. So we're in the middle of huge scale up, reaping one-time gains this decade, and progress to the ohms will be multiplied slower thereafter. Spending scale up. Spending $1 million on a model used to be outrageous. By the end of the decade, we will likely have 100 billion to $1 trillion clusters. Hardware gains. AI hardware has been improving much more quickly than Moore's law. That's because we've been specializing chips for AI workloads. Of course, age stalls with FP8, 16, etc. Those speedups are incredibly powerful when training and doing inferences. Algorithmic progress. In the coming decade, AI labs will invest tens of billions in algorithmic R&D, and all the smartest people in the world will be working on this. Again, this is probably the final frontier for humanity. Maybe it's enough, and we will get AGI soon, or we may be in for a long, slow slog. So this was the first part of the situational awareness essay. Quite intriguing, isn't it? Thanks for watching, guys. Please like, share, and subscribe. Also join the Discord channel that I'm going to link down into the description. And if you want to continue with reading through the next couple of parts, please let me know down in the comments below. Thank you for watching, and I'll see you in the next one. Bye.